Today I'm going to do 3 examples of solving linear systems using the substitution method. Now the substitution method is a great method to use when you're giving a system of equations that has one of the equations already set as y equals something or x equals something, or if it only takes a one-step process to turn it into that form. So let's review our 3 ways that 2 lines can intersect. So we have first way here, which is they intersect at a point. And when this happens, we have a consistent and independent system of equations. Our next way is when 2 lines are the exact same, which means that they have an infinite amount of solutions. We call this a consistent and dependent system of equations. And finally, our last way is not having the lines intersect at all. We call this an inconsistent system of equations, where our 2 lines have the same slope, but have a different y-intercept. So let's look at the first example here. So example number 1. So let's look at 3x plus 2y minus 1 equals 0, and x equals y plus 2. So what helps me out is I like to number my equations, and that way it makes my method a lot cleaner. There's less likelihood of me making a mistake. So I notice that in my second equation, it's already set as x equals something. Okay. So what I want to do is I want to sub that equation, so it's sub equation 2 into equation number 1. And in doing that, I get rid of my x variable in my first equation, and I'll be solving for my y variable. So I'll show you what that looks like. So subbing 2 into 1 gives me 3y plus 2 plus 2y minus 1 equals 0. Now again, this y plus 2 came from summing in my second equation into my x value for my first equation. Okay, so now I can distribute my coefficient throughout the bracket. So 3 times y gives me 3y, plus 3 times 2 gives me 6, plus 2y minus 1 equals 0. Now I can collect my like terms. So 3y plus 2y gives me 5y. And then 6 minus 1 gives me plus 5 equals 0. Now in order for me to solve for y, I need to isolate my variables on one side. So I'm going to keep 5y on my left side, but I'm going to move my 5 over to the right side of the equation. And in doing that, it becomes negative 5. Now to solve for y itself, I divide both sides by 5, and I get the answer y equals negative 1. So I'm not done. So far, I've only found out where my 2 lines intersect at the y-coordinate. So let's picture this here. Think about if I have my graph, and I know that my y-coordinates are going to intersect at negative 1. So let's say it's down here somewhere. So for all I know, my system could look something like this. Okay, I just don't know at what value of x they intersect at, which brings me to my next step. So now I need to take y equals negative 1 and sub it into one of my 2 original equations. Now, looking at these 2 equations, number 2 looks a lot easier. Okay, so I'm going to sub y equals negative 1 into 2. So I'm going to write this out. Sub y equals negative 1 into 2. And that gives me x equals negative 1 plus 2. Okay, and adding my integers, x equals 1. So I know that therefore the lines intersect at 1, -1. And again, I'm going to square this to keep it organized. And again, your teachers will really appreciate when you guys make your answers really visible for them. So again, therefore the lines intersect at 1, -1. I'm going to say system is consistent and independent. And again, I know that it's consistent and independent because my two lines intersect at one point. Okay, so that's how you solve that system of equations there. Let's look at a second example. So in example 2, I'm going to have 2y plus 4x equals 18 and y equals -2x plus 9. Okay, so example 2. Okay, so again, I'm going to label my equations 1 and 2. And because equation 2 is already in the form of y equals something, let's sub 2 into 1. Okay, and in doing this now, I'll be solving for my x-coordinate. So 2, -2x plus 9 plus 4x equals 18. So again, this 2x plus 9 came from my second equation, and all I did was I subbed that into the y from my first equation. So again, let's distribute the brackets here. 2 times -2x gives me -4x plus 2 times 9, which gives me 18. Then I continue to write out the rest of my equation. Okay, so let's clean this up here. I'll have my variables on one side, and then I'll bring over this 18 onto the other side. So I have 18 minus 18. So now let's solve this here. So -4x plus 4x gives me 0x equals 18 minus 18 gives me 0. Okay, so what's going on here? We have 0 times something equals 0. Well, let's say, for example, what if I subbed 1 in? What if I subbed 1 in for x? Well, 0 times 1 is still 0, so 0 equals 0. So that makes sense. What about if I sub 2 in for x? Equals 0. 0 times 2 is still 0 equals 0, so that's right. So it does not matter what value I sub in for x, this equation will always hold true. This means that when I have my two lines, they will have the exact same x value throughout their whole line, which means that these two lines actually lay on top of one another, meaning that this is a consistent and dependent system. Okay, so the one thing you want to look out for is this equation right here, 0x equals 0. When you see that, you know right away that you are going to have a consistent and dependent system of equations, because the two equations are going to lie on top of one another. They're going to have the exact same slope and the exact same y-intercept. Okay, so that's example 2. Let's go on to example 3. So in example 3, I have 2y, I shall write out example 3. I have 2y equals 6x minus 2 I'm going to label that equation 1. And equation 2, I have 3x equals y plus 4. Okay, so let's look at these two equations here. You can both, well, neither of these equations are in the form of y equals something or x equals something. So we can change one of them, or we can manipulate one of them into becoming that form by doing a one-step process. Well, let's look at equation 1. If we divided each term by 2, then we would get y equals 3x minus 1. Okay, so let's make that our new equation 1. So I can cancel this one out here. Okay, so let's go on to our next step. So because we have this as y equals something, let's sub 1 into 2. So in doing this, I get 3x equals 3x minus 1 plus 4. And again, all I just did is I just subbed in 3x minus 1 in for my y value. Now again, let's go through the brackets here. There's nothing in front, so I can drop my brackets. Okay, now I'm going to clean this up. I'm going to have my variables on one side and my constants on the other. So I'm going to bring this 3x over to the left side here. So I'll get 3x minus 3x equals negative 1 plus 4, which gives me 3. So 3x minus 3x gives me 0x equals 3. So this is kind of like the example we had prior to this one. However, we notice that now 0 times something must equal 3. Well, let's think about that. 0 times any number is always going to be 0. It will never be 3. So this means that if we have our system of equations here, we're going to have one line, again, so let's just call it there, and our other line will be here. The reason why we cannot find a solution for x is because these two lines never intersect, okay? So whenever you see 0x equals some other number other than 0, you know right away that you have a inconsistent system of equations that does not give you any solutions. So thanks for watching, guys. If this video helped you, remember to comment, like, and subscribe.